Hi, everyone. We'll be waiting 2 to 3 minutes before starting the webinar, just simply to accommodate for the rest of the attendees who are in the middle of connecting. Welcome, everyone. Thanks for joining us, and thanks for being part of our community. My name is Valen Kolika, and I'll be your host today. Our co-hosts are also here, Ryan Heffernan, Jason Cohen, and Ashley Martin. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community page at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at your lower right corner of your screen. Now, please feel free to ask questions at any time by typing them in the live event Q&A window, simply by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously, and you can do so by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you have additional questions, please post the questions on our tech community forum. Simply where you have registered for this webinar, that will be the venue for that. We love to hear your feedback on how we can improve on these webinars, and you can do so at aka.ms/security-webinar-feedback. And by the way, all the links that I'm announcing have been already shared with you on the chat or live event Q&A window. I would also like to invite you to join our public community by visiting us at aka.ms/security-community. That's the best way to ensure that you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products, and you'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which, by the way, you can sign up for it at aka.ms/prsec.com. In there, you can request the features, give feedback, review our product roadmaps, register for our events, or join webinars like this. We simply believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Andrew Jenks will go over the topic of combating manipulated media, that media provenance that is. Andrew is a principal program manager with our Microsoft security team. And without further ado, I'll turn it over to him. Andrew, the floor is yours.
Thank you, Vilan. All right. Let's get started. So as Vilan said, my name is Andrew Jenks, and I run the Azure Media Security team. I also co-head the Microsoft team on media provenance. I'm the chairperson of the Coalition for Content Provenance and Authenticity, and work on our work on manipulated news media with Project Origin. I'm here today because people are trying to change what you think and how you relate to the world. They're directly messing with who and how you trust, and they're impacting your sense of belief. You may have already fallen victim to it and not even known, and I can freely admit that I have. I have had issues with manipulated media in the past and determining what is real and what is fake. Today,
I'm sorry to interrupt. Can we try to reshare your presentation once again, please?
Better?
Yes.
All right. Back to it. So today I'm here to give an introductory talk on combating manipulated media, focused on media provenance. This is, think of this as a 100 series talk. So it's a broad introduction and basis for education instead of a deep technical talk. I'm supported today by a team of our experts on media provenance and manipulated media that are here with me answering your questions in chat. And available to answer questions at the end of the session. So please ask us anything that you have. We'll have time for Q&A at the end, and we look forward to addressing any issues or questions that you have. So, by the end of this talk, you'll be able to answer 3 fundamental questions about synthetic media. What is it? How can we help prevent it? And what are we doing in this space? And we're doing this talk today because of headlines like these. If you read the news, you've seen stuff like this. These headlines are scary and they're real. We're seeing synthetic media play a role in major events such as protests, military coups, and disease transmission. This is a critical and growing problem to solve now. In the past, I tried to keep this slide updated with the most recent headlines related to synthetic media, but frankly, the prevalence of synthetic media stories has become such that that's no longer possible. But I want to be clear, this is not a new problem. This image was one of the first widely circulated photoshopped images, and it hit the internet in 2001. It predates social networking, it predates major sharing, but it was very popular and shared very widely. Even before this, we have examples of photographs, physical photographs that have been edited and manipulated. So what makes manipulated media a problem now? What's changed? Well, in the past 20 years, tools have gotten easier, cheaper, and more available. They've also expanded from the ability to edit still images to video. When this image was first created, a copy of Photoshop cost $20,000. You had to have a hardware key to use it, and you had to have a very expensive, very powerful computer to be able to generate these images. Today, Photoshop is available by subscription for, I think it's around $13 a month, and it'll run on any commodity hardware. So the scale and the reach of these technologies has increased markedly over the past 20 years, just as we've seen all technology get democratized and more powerful. When we talk about synthetic media, deepfakes get all of the headlines and a lot of the mind share. But it's important that we recognize that synthetic media isn't just deepfakes and that it doesn't just have negative effects. There can be positive impacts on people's lives from synthetic media as well. For example, we can add captions for the hearing impaired using synthetic media. We can have fun with phone apps like Wombo and generate synthetic media of our friends. Malicious synthetic media, though, is any synthetic content that's built with the intent to harm. This can include trivial media manipulations and changes to the media. Deepfakes, which again get all the headlines, are really just a subcategory of malicious synthetic media. They use more involved AI and ML techniques to generate better images, but all forms of malicious synthetic media can be problematic. To further illustrate this, I wanted to provide 3 real-world examples. So the first video on your left is an example of a cheap fake, where the original video was slowed down to make it appear that the Speaker of the House was intoxicated. This was a trivial manipulation to the video. It didn't require deep and powerful techniques. It was a fairly simplistic edit. The Mark Zuckerberg video in the middle of your screen is a deepfake. His lips were edited and changed, and a new audio track was inserted to make him say outlandish things that he probably wouldn't say in real life. This video, when it was released, was widely circulated and had a material impact on Facebook's stock price. Another big problem is that attackers and well-meaning folks reuse previously published images in different contexts to try and convince the viewer that the photograph provides evidence supporting some invalid or malicious claim. On the right side of your screen, you can see the same image of the same fire being attributed to 5 different locations, none of which are what that picture was initially of. This was attributed from everything from the rainforest in Brazil burning to my personal favorite. There's a claim that says that this shows the Arctic burning. So why is this a problem now? As we talked about, it's all about scale and accessibility. Authenticating trusted sources used to be really easy. Nobody faked the New York Times that was delivered to your doorstep. Nobody faked the local news that you got over your antenna because it was hard and there wasn't much value in it. And if you go to a site, if you go to the BBC site using SSL, you can be pretty sure that the content that you're getting is what the BBC actually published. You as an end user can use these same strategies today to get a better idea of trusted sources. So if you have information that you're seeing that you're not sure is true, go back to the basics and use easily authenticated trusted sources to determine whether something is true or false. So nobody does that though. Today, people get their news from YouTube, Twitter, and Facebook. Social networking is the dominant way people consume news today by far. In one study, 10 times as many people viewed a story on Facebook as they did the original story on the BBC. And that's just one story on one network, and it wasn't a particularly popular one. And on social networks and on other distribution points, when you go through this double hop of content, you can't tell that what you're looking at is exactly what was published. There's no real way for you to figure it out. So we leave the problem of detecting fake images and media on social networks to end users. And end users are terrible at it. Like they're really terrible. The majority of people don't trust in their own ability to tell if a piece of news is real or fake. They don't think they can be sure. This stat is getting worse even as the amount of news being consumed from social networks is increasing. We also have a time problem. News stories themselves are temporary. They only last for about 72 hours in the popular ecosphere. So you only have a few hours to impact incorrect reporting before the damage is done. And people watching videos on social networks tend to watch less of the content, ignoring clues that may be available that demonstrate that media is falsified. All of this adds up to a big problem, not just for you, but for society, for businesses, for democratic processes, for journalism, and for others. Real harms are being done in all these areas. People are losing faith in journalism. They're losing faith in leaders. They're being exploited in media. And oftentimes it's being done on the back of media that's simply fake. All of this is a form of cognitive hacking. And cognitive hacking is changing what people believe, even when those people are making very rational, very reasonable trust decisions based upon the evidence that they have. This gets even worse. It turns out that when there's a certain amount of disinformation in the world, people believe less true information as well. This is called the liar's dividend, and it's a fascinating topic. It's worth research or a talk in its own regard. But effectively, what it boils down to is that when anything can be a fake and you can't tell, you lose the ability to tell if anything is true. That directly harms your relationship with reality. It directly harms your ability to interact with the real world. So if this is a huge problem and it needs solving, what can we do about it? Well, we actually have lots of tools in the toolbox that we can bring to bear to help make this better. We can make people smarter about the media they consume. We can institute new policies on platforms to help protect users, and some social networks have been leading in this regard. We can pass laws and make new requirements for what can and can't be shared, but that's kind of overbearing. And we can also develop and deploy technical solutions. And that's where we'll be focused for the remainder of today. When we think about technical solutions, there are really three areas for manipulated media that we worry about. Detection is the ability to automatically determine if something is fake. Authentication is the ability to tell if something came from a trusted source. And provenance is the ability to get additional information about a piece of media that helps you make an educated decision about it. Everyone jumps to detection first as a solution for manipulated media and deepfakes. It sounds absolutely great, right? Just build technology that tells me whether the thing I'm looking at is real or not. Tell me when I'm being lied to. And this is a very active area of research. There are a lot of techniques that have been developed in just the past few years to try and tell when an image or video has been manipulated. I'm pleased to say that Microsoft Research and teams around Microsoft are leading some of the major developments in this space, using some of the techniques listed on this slide and developing new ones all the time. One great example of this is Microsoft Video Authenticator. It was built to detect manipulated media, and it's one of the better detectors out there. It's currently being used in newsrooms today to help tell if incoming citizen journalism is real or has been manipulated. And it's a very helpful resource and tool for newsrooms around the globe. So if detection is great, why do anything else? Why not just rely upon this? It turns out detection is what we call an arms race. If you build a great detector, you can combine it, you can put it in a loop with a malicious media, a deepfake generator, and train your generator to make malicious synthetic video that can't be detected by your detector. So if you make your detector public, what you're actually doing is making the malicious media generators better. Today, the best AI detectors are only 60 to 75% capable. They miss a quarter of falsified information, and that success rate appears to be going down over time. And if you misidentify media, you're back to the liar's dividend. where you can't be sure whether something that has been detected to be real is actually real or fake. And in this regard, both false negatives and false positives hurt the end user. You can either amplify stories that are false, or you can diminish stories that are true. So if detection isn't a panacea, what about authentication and provenance? Can these techniques in combination with detection help us filter information and provide better information to end users? So let's start with what media provenance is. Media provenance is the idea of being able to get additional information about a piece of media that allows you to make a better decision about it. That may include information such as who published a piece of media, when it was created for an image, what day it was created, or even the entire chain of possession that goes all the way back to the digital camera that initially took an image. If you're familiar with EXIF data and the ability to provide unsigned metadata in things like MP3 files, where we were provided with track names for years, this is really similar. The difference between media provenance and things like track names and MP3 files is that media provenance uses cryptographic techniques to prevent changes, to prevent manipulations to it. So it travels through the process of media production unchanged. It's important to note that everything here is optional and opt-in because privacy and anonymous content is a huge concern. It's also removable if this is something that you don't want to share. Provenance data comes with metadata in something that we've called a manifest. That manifest is cryptographically bound to the media asset through hashing of the actual image or video, and it's signed by the creator. Think of this process as taking the bits of an image, taking a fingerprint over those, just like your fingerprint, a unique identifier over those, and using that information to link the metadata to the actual content of the image or video that you're looking at. When you validate the manifest, when you check to make sure that it's accurate, you can be sure that the information in the manifest is what the publisher put there and that the actual asset hasn't been edited on its way to your eyes. So it survived that double hop that we talked about intact. A manifest has 4 parts. It has those fingerprints for the asset itself. It also has metadata. For example, if I was creating a provenance manifest for this session, I might put in the title of the session, my name is the speaker, today's date, whatever information I want. Whatever information is important for your specific media scenario. It can, but doesn't have to, also contain any edits that you made to a file. So if you started with an original image but photoshopped it, you can include the edits that you made to tell other people what changes you made to the image to provide greater information about what manipulations may have taken place. Because as we said, not all manipulations are harmful. And finally, it contains a digital signature over all the data above to link it back to a certificate that shows who is providing this information, who is vouching for all this stuff. And that certificate might be a corporate entity like the BBC, or it might be me as an individual that holds a certificate that wants to say, I am a creative, a photojournalist, and I created this thing, and I want attribution for my image. So what's important here? This system, as we've developed it, is as strong as well-known cryptographical processes. An end user or user agent can validate the video at consumption time and make sure it's unchanged since publication. that information can be bound directly to common media formats. We've solved for the ones listed on this slide, but frankly, we think there are a lot more that this applies to, and that the techniques that we've developed are generally applicable to digital assets. So think of provenance as applying to anything on your computer that you want to share with another person, and you want to provide additional information and tamper-proofness to. Most importantly, all of this works in the clear media space. So it doesn't break any of the existing infrastructure that we have on the internet today for viewing, editing, or creating images or videos. Those of you with PKI experience or familiar with security might be asking yourself a very basic question right now, which is, why is this hard? Why not just add a manifest, sign the asset, and be done with this? Why is this not technology that we already have? And that's a really, really good, insightful question. Let's talk a little bit about why this is complicated. And this is the part of the talk where we get into the guts of how media actually works on the web. And it's going to be focused on how video works. This is the deepest we'll get into the technology involved here in this talk. So if this is beyond a level that you care about, stick with me for a little bit. We're going to bubble back up. A video on the web isn't really one video. It's not one thing. YouTube provides a great example of this. When you upload a video to YouTube, what YouTube generates is actually 16 separate video-only streams, 2 audio-only streams, and 3 streams which include both audio and video. So one upload very quickly becomes a whole bunch of different files, a whole bunch of different things. So signing that original file doesn't necessarily make it through that process because the media is changed during this process of what we call transcoding. So if we can't sign the original file and be done with it, could we just sign all of these assets and know that they were unchanged since the time the file was uploaded? It turns out no. Because of something called adaptive bitrate streaming, which poses another problem. Clients, viewers, when you consume a video, can dynamically switch streams to optimize the viewing experience. You may have noticed this happening when you see a video go from a lower resolution to a higher resolution. You're changing streams during playback. So provenance manifests are designed to support adaptive bitrate streaming to handle this problem. So the key insight here is that uploading one video results in multiple things, and when you watch it, you're actually watching multiple things. When you have different media assets being created from a single thing, and then different assets being played back, we have to figure out a way to develop manifests that can support that scenario. Because again, that's how video works, and we don't want to break how video works on the web today. Provenance's manifests are designed to support these through things we call facsimiles. And what we do is hash individual chunks for each of the facsimiles and store those chunk hashes in a manifest. This architecture allows clients to be able to easily authenticate any facsimile that the user wants to play quickly and with minimal download of extraneous information. So you can start validating a video as soon as you watch it without waiting for the entire thing to download. This helps protect against attacks where only individual chunks or frames of a video are changed to significantly change the message. Media can also undergo legitimate or illegitimate transformations where a manifest on the transformed media might be lost. In order to deal with this, we're exploring the use of things called soft bindings and watermarks, which can be recovered by the media player and provide information about the original media object and perhaps a URI corresponding to a service hosted by the publisher, which can be used to authenticate the media and get potential manifests for it. Things called candidate manifests, ones that might match the asset you're viewing and that you can use to determine for yourself whether something has been manipulated or not. This ability helps when you're bringing up a brand new ecosystem and none of the tools support this technology yet. One of the key things we have to do is bootstrap the provenance ecosystem. And right now, tools don't support this technology. They may not pass through the media provenance manifest in the natural course of production. And so you have to have a way of finding that thing, even if it's scraped off, removed through a tool that doesn't support provenance, or maliciously removed because I don't want you to know that I have changed the content of a video. So if that's the rough overview of the technology, let's talk a little bit about where this is being developed, because provenance in media is a huge problem and no one player can solve it. No one company can change the bits that need to be changed in order to bring this solution to light. Microsoft has been working with other companies and forming standards bodies to address the problem all across the industry, all across the video ecosystem. This is a huge cross-industry effort, and I wanted to give you a little insight into the roles that different industry players are playing and where this work is being done, because I think it's important that you have an idea of not just what the technology is, but who's involved in making it real. There are three main bodies that are kind of leading the public charge on media provenance. They are Project Origin, CAI, or the Content Authenticity Initiative, and the Coalition for Content Provenance and Authenticity. Project Origin was formed by Microsoft, excuse me, the BBC, New York Times, and CBC a few years ago. It was formed based upon a high-level conversation amongst the four on the concern that deepfake videos presented to news agencies. Project Origin is focused on provenance from really the point of production, the point of publication of a story from a news agency to the point of end user consumption, where someone gets that story from, regardless of whether it's on a first-party site or shared across a social network or some other site. It was particularly focused on news media scenarios and particularly video scenarios. At the exact same time Project Origin was investigating that, Adobe created something called the Content Authenticity Initiative. And that Adobe-led CAI was investigating the same provenance problem and the same attribution problem, particularly for still images, from the point of capture on a camera device to the point of production or editing. So it was the same problem looking at an earlier part of the problem space and a different content type. These two problem spaces, when you put them together, covered provenance scenarios all the way from the point of capture to the end user point of consumption. And so these two groups got together and decided that there were probably a lot more uses for provenance generally, and critically, they should develop a solution that was interoperable and not specify how this stuff works twice. We want this to work well in the ecosystem and be compatible from tool to tool. So they decided to form a standards body specific to provenance. And that body was called the Coalition for Content Provenance and Authenticity. It's really the center of gravity for where provenance work is being done today, and works closely with these agencies and other verticals to produce interoperable specs and standards for provenance. Let's think of that as where the solution for provenance is being built. This slide shows how these organizations relate to each other and the wider industry. And again, this is an ecosystem-wide problem, right? All of these bodies have to work together. They have to work with consuming organizations in order to make a solution here real. So CAI and Origin are gathering workflows and requirements from their industry partners. They both work with a wide range of partners, numbering in the hundreds, to make sure that the solution that we're developing in C2PA meets the needs of folks who will actually adopt it. They're providing that information to C2PA, which is turning those requirements and workflows into technical standards. C2PA is then publishing those specs publicly, using CAI and Origin to scale uptake and provide best practice information, reference information, adoption guidance to consuming organizations. And finally, organizations like news providers, cloud providers, and social networks will use the tools that support provenance to publish media to the end users, who will be able to know where it came from and get additional information about the media. So since C2PA is the center of gravity here, I want to dig a little bit into what they're actually doing and what their mission actually is. And their mission is very simple. It's to develop technical specifications that can establish content provenance and authenticity at scale to give publishers, creators, and consumers the ability to trace the origin of media. And what that means is that C2PA is creating that base layer for provenance solutions to make sure that all the various ecosystem players play well together and interoperate. C2PA is a very transparent organization. It publishes its charter and guiding principles on its website, and you can find them on that link below. I want to be clear, this isn't work that's happening in an ivory tower somewhere. This is work that we've invited literally anyone and everyone to review, to participate in, and to make sure that we're addressing both the needs and the potential misuses of the technology so that we can build the absolute highest quality spec that meets the most number of use cases. All of this information, including the full draft specification, is available on the website listed on this slide. But what's the real work that's actually being done here? So C2PA is focused foremost on gathering requirements for provenance scenarios and producing those interoperable specs, standards, and recommendations. They want to ensure that those specs are widely leverageable in the actual marketplace. Those specs will eventually become international standards through groups like ISO, ETSI, and W3C. C2PA will also help drive adoption in concert with their industry partners. And finally, they'll ensure that none of this breaks the media ecosystem that exists today. Any media player will be able to consume media provenance. If that media player is provenance aware, it will simply provide you as the end user with more information about the media that you're consuming. This is an additive technology. This isn't fundamentally changing what we have today or how the web works, how media works on the web. Like I said, enabling media provenance is an ecosystem-wide solution and requires, or an ecosystem-wide problem and requires an ecosystem-wide solution. To enable that, C2PA itself is made up of a broad range of collaboration partners. Members span the gamut across news media organizations, technology providers, cloud service providers, and social networks. But I think it's important to note that other notable members include companies like Witness, a nonprofit that's focused on citizen journalism. They're particularly worried about issues of anonymity and privacy, and have helped the entire organization ensure that those concepts are baked into the specifications and standards from the ground up. We don't want to break anonymity on the web here. This isn't an effort to track everything that's done on the web. What this is an effort, if you want it, to provide additional information about media, to provide attribution for photojournalists, and to provide you as an end user more trust that what you're looking at is what the publisher actually published, regardless of how it got to your eyes. So the close collaboration amongst peer companies really gives me great hope that we can change media consumption for the better, because all of the folks involved in the media ecosystem are represented in the membership of C2PA, and we're growing this over time very, very quickly. So what do I want you to take away from today? Synthetic media is a large and growing problem. It's getting worse as time goes on, and what got us here in terms of authenticating trusted sources won't get us through the future and isn't getting us through the present. We need new tools and new ways of thinking and dealing with malicious synthetic media. Microsoft, along with its partners, has innovated a solution based upon provenance and authentication, and that solution is being standardized in C2PA today. And the applicability of provenance across scenarios is extremely broad. Trust is a universal need, and we are investing in a universal technical solution. So that's what I want you to learn. What do I want you to do as a result of this presentation? First, check yourself. Before sharing a story on social media that's hard to believe, check your sources. Take those 30 seconds to go to the purported original site. Ask yourself, does this seem unlikely? How do you know it's true? Talk to your friends, your family, and please, please talk to your children about the prevalence and the dangers of synthetic media. Talk to your legislators too. We have to educate users. And now that you've viewed this session, you know more than most about the problem. You personally can be part of the solution. Finally, if you think you have a use case or a desire to further talk about provenance, get in touch with us. We're always on the lookout for new scenarios, and I'd love to chat. C2PA, Project Origin, CAI are all very receptive organizations that would love to talk to you. If you have interest in any of these groups that we've discussed today, I'm happy to connect with you, and you'll be able to get my connection information from the events page for this event. That brings me to the end of my presentation today. And with the help of our subject matter experts from across the Microsoft Provenance team, we'll be happy to take any questions from the audience. Please enter your questions into the Q&A section of the Teams. And now, Vilan, back to you.
Thank you so much, Andrew. This was very helpful information. The team did great here in the background. They answered to pretty much all the questions, but I believe there's still some questions that the team may laid out there for you, and perhaps elaborate on that one. Anything from you guys?
Maybe I'll pass this one. This was the last question. Pass it over to Andrew. Could you talk about the what's the same and what's different between a provenance solution and a DRM system?
Yeah, so it's incredibly important to differentiate those two things. DRM is really about the rights management of a piece of technology. And for those who might not be familiar, DRM technology is the security technology that underlies streaming services like Netflix. It's the security component that keeps you from being able to steal a Netflix video that they've licensed and publish it to BitTorrent. So that's really about protecting content and controlling where it can flow and who can access it. Provenance is completely different. Provenance takes place in the clear media space. For provenance solutions, you want folks to be able to widely access information and not really control where it flows or who can view it. Now, you can think of those two solutions working together, where you would want something like attribution for a piece of content and you would want security over it. But it's important to differentiate those two things. Provenance is not DRM, and DRM gets a lot of bad press. for its control aspects. Provenance has no control aspects. This is not about exerting control. This is about providing additional information to end users.
Perfect. Thank you. There was a interesting feedback earlier. Let me just try to find it here. Oh, will the video manifests be integrated into Azure Purview? I'm not sure if we can talk much about it. I did provide some information about our private preview, as this is our public webinar. But if you have something that can be publicly shared on this topic, Andrew, feel free.
So Microsoft has invested very, very heavily in provenance research and provenance technologies over the past several years. That's why we're involved in Project Origin. That's why we're involved in C2PA. That's why we're involved in CAI. We believe that there is a public good, and Microsoft has a corporate responsibility to try and do good and prevent harms where we can. So although we have no product announcements to make, we are actively looking at where we can bring this to market to help our users and to help our end users and provide greater functionality for the overall media ecosystem. Microsoft is a huge player in the media ecosystem with services like Azure Media Services today, and those would be natural landing spots for provenance support in the future.
Great, thank you. Here's the next question. Can we have a kind of blockchain security on the publishing objects for a corporate website?
Oh, I love this question. Everybody asks about blockchain. It's such a great buzzword, right? So the provenance technology itself does not require a blockchain solution. That was one of the first things that we solved. We started with the blockchain solution, and we figured out over time how to embed manifests directly in pieces of media content so that they could travel with the media as it goes from site to site and is republished over the internet. However, we know that the provenance standards are compatible with blockchain solutions. And it's fairly easy to imagine someone like, let's say the BBC publishing manifests for all of their public stories on a blockchain to provide you things like transparency over when those were published, tamper evidence, distributed redundancy, right? And so we think these technologies are complementary. And although C2PA itself isn't standardizing anything to do with blockchain today, it is an area that we're investigating for the future to try and determine if there are solutions that should be brought to bear that combine those two technologies. So one doesn't require the other, but it is possible that one be made better with the other.
Great, thank you for the thorough answer. I think, let me check, do one more. Looks like, there's one more. When I create image or take photo, how could I submit the information to C2PA?
So you won't be submitting that information to C2PA. C2PA is a standards body. They're producing the technical standards that tell you how to create media with provenance in it. What you'll actually be doing is using tools that support C2PA. So those tools might be either hardware-based or software-based. There's a company called TruePic today whose entire business model is around producing camera technology that embeds provenance information directly into images. And it's heavily used in things like the insurance segment, where you can take a picture of your wrecked car in order to file an insurance claim. The insurance company needs to know if you took a picture of your actual car, or if you went to a junkyard and took a picture of another wrecked Civic and said, "This is mine, please give me $12,000 to replace it." So those tools and technology are how you'll interact with what C2PA is doing. Now, again, I want to point out that as written in our guiding principles for C2PA, we believe that all provenance information should be optional and should be opt-in. So this isn't a case where when I use my iPhone and I take a picture, everything gets tagged with my name. But it is a case where I have the option of putting information in if I so desire and want it to travel with my image and with my media. So hopefully, as the ecosystem solutions develop, you won't have to worry about submitting this thing. It will be a natural part of the tools that you use today and that you'll continue to use in the future.
Thank you, Andrew. I think that was it as far as questions. Thanks again for providing this very valuable information at a perfect time here with our public community. And just as a reminder that the best way to ensure that you don't miss any future webinars or major announcements, please visit our landing page at aka.ms/security community. In there, you'll find easy ways to navigate and find resources and learning content relevant to our security products as well as their communities. And I suggest a good start would be to browsing our bite-sized product videos, the ninja trainings we have out there, as well as the recordings of past webinars and their GitHub communities. I would like to close this webinar by thanking all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.
Thank you so much.